Chromatic dispersion is a major limiting factor in high speed transmission. Okay, so let's understand this. We have a formula L is equal to 104,000 divided by CD into B square, where L is equal to link distance in kilometers, CD is equal to chromatic dispersion, B is equal to bit rate, and note for fixed fiber type and fixed wavelength, the L is inversely proportional to bit rate. You can see here. We are considering a typical network transmitting data at a 10 Gbps rate, and the channel is 1550 nanometers over a standard G065 fiber, having a CD value of 17. In this case, the theoretical maximum distance of the link before adding CD compensator will be around 61 km by using this formula. This length will be divided by 16 when upgrading the network to a 40 Gbps bit rate. Hence, the length would be 44, only 4 km. So you can see if the rate is increased from 10 Gbps to 40 Gbps, the approximate length from is reduced from 61 km to 4 km. We can increase this distance till around 20 km for a 40 Gbps by replacing the fiber to non-zero dispersion shifted fiber. So if we change the fiber, we can increase the distance. But if we are making this fiber constant, if we increasing this bit rate, the length would be decreased. Hence, we are seeing that a CD is a major limiting factor in high-speed transmission. You can see here, this is the TX, this is the RX meter, this is the fiber span, and this is the dispersion module. So suppose if you are using G065 fiber and we are using the 10 Gbps speed, then after 61 kilometer, we must use the dispersion module. If using the same fiber and the speed is 40 Gbps, then we have to use after every 4 kilometer dispersion module. So you can see here in this diagram, this is the bit rate and this is the in case of SMF fiber where the dispersion module is 17 ps per nanometer kilometer. So for 2.5 bit rate, 2.5 Gbps, its maximum distance is 900 km. For 10 Gbps, it's 60 km. For 40 Gbps, the length is 4 km. And in case of non-zero dispersion shifted fiber for 10 Gbps bitrate, the distance is 350 km, and for 40 Gbps, the distance is 35 km. So in case of high-speed transmission, CT is a major limiting factor. So we cannot neglect it, and we must introduce this chromatic dispersion in case of high-speed transmission while making the optical budget. Okay, thanks.